So what I have here is a Alco C430 by Tyco, probably made in the 70s, thereabouts. So what I want to do is I want to convert this DC locomotive to DCC, and I want to take the power torque motor that came with this locomotive out. The reason I want to take this power torque motor out is just because it's not a very reliable kind of drive, and so I want to upgrade it to something more modern with a flywheel. To do that, I'm going to be using this Hobbytown of Boston kit, specifically this Universal Road Switcher power chassis 77408 U28B. So this is a kit which you put together yourself, made from Hobbytown of Boston. So the first thing we're going to want to do is you're going to want to take the shell off this locomotive. And to do that, you'll need a flathead screwdriver. So again, just work your way around the shell. Go nice and slow. Just to, again, pry that apart and get all the pieces free. We're not going to be using any of these pieces, but you want to be careful not to crack the shell. So there's the first part. Again, you'll do the same for the rear, and you'll do the same for the weights, and then you'll free the chassis from the shell. So you can kind of see this is quite a bit of work here. It's taking me some time, but the fuel piece right here just comes right off the weight, and I like to use toothpicks to sort of wedge apart this weight away from the shell, and it's just held on by clips. So use a bit of force to get this off, but just kind of be careful not to crack the shell. So we got the components free from the shell, so it's up to you what you want to do with them. It's a power torque drive, and you could either resell it, maybe put it in a Tyco for a friend who needs one. I don't know. It's up to you what you want to do there. We don't really need these parts. You can decide what you want to do there. We need the shell. So we'll have to have a look at that a little bit later, but the shell requires some milling in order to fit the new chassis. So we'll look at that later. Like I said, we're going to turn our attention to the Hobbytown kit now. So inside the kit, you get exploded parts diagram as well as instructions. Got all the pieces here. You get a flywheel. In this case, 3 flywheels. It looks like your fuel tank assembly and all the screws. You get a motor. Truck side frames and trucks, and you get the chassis, business card, and product identification, registration, whatever. Okay, so the first thing we're going to want to do is we're going to want to clean up the chassis here. So you can see here some flash which needs to be filed away. You can see it all over the model here. So all this will need to be filed. As well, some of these holes you may need to make them a bit larger, but we'll come to that when we need it. But for now, if you see any flash on the model, get your file out, and I have a couple of jeweler files which I use. Where are they? Anyways, they're around. Oh, here they are. So I have a number of different files, like small jeweler files, which I use. So that's what you'll need to complete the project. Okay, so I'm just going to clean up the chassis right now. Okay, we removed a little bit of flash, not too much, cleaned up the model. Okay, because I've built this before, I'm just going to tell you how to build just the Alco C430 for the Tyco. There are other models you can make using this chassis, but this one's just going to cover the Tyco C430. Now, for this particular chassis, it's going to need to be cut to fit the shell. It's simply too long. So from the rear of the locomotive to this point is exactly 98 millimeters. Okay, I'm going to cut on this side of the line. So you'll need a small miter box and saw, and you'll need to cut through on that line. And there's my miter box and my saw. So we're just going to start cutting. Okay, we've cut the two pieces. This might be a little too long. It's okay if it is, because we can always file and cut and make it a little shorter. Next thing you'll need to do, taking the rear end of the chassis again, you'll need to cut off this tab on each side of the chassis. So there's two little tabs here. They're not needed, so we're going to have to cut those off. We can then turn our attention to the front of the locomotive, because a little bit of this partition here has to be cut. Okay, so again, get out your miter box and your saw, right? And you're going to have to put the chassis in. You're going to have to cut off these little tabs, like I said. Turns out I don't really need the miter box for this step, so I'm just using my saw and just holding the piece down like this and just cutting these two pieces off. Okay, I've cut these two little pieces off and did some more filing, and I've taken the fuel tank out, and I've filed off all the flash and the other pieces here. So I got quite a bit of metal filings here. Anyways, looking at the shell now, since I cut off these two little clips, I'm now able to put the rear half of the locomotive inside the shell. Like, the shell still has to be milled out a little bit in the inside just to have a proper fit, but we get the general idea how much room it's taken up so far from one end of the coupler pocket to the midsection of the locomotive. Now, I just got out my measuring tape here, and I just measured exactly 100 millimeters from the point that we cut to the coupler pocket here. So I'm going to measure that out on the other piece of our chassis, and I think we'll need to cut off a little bit from this end. Again, we want that end. We don't necessarily need this much material right about here. So 100 millimeters is about the measurement. I'll have to do a double and triple check, but that's the initial measurement I got. Then once that's done, we'll go ahead and put the fuel tank on. So I went ahead and just cut these little clips off. We're going to want to cut we want that hole right there in front of my finger. So this part right here, we're going to want to cut that off, keeping the hole. So I'm going to cut that off, and then we'll want to join it to the fuel tank. Okay, what you really need to do, get yourself a measuring tape. I find that's the best thing to do. And you're going to measure exactly from where the coupler pocket would go in the shell, from one side to the other. And measuring this exactly, like to the millimeter, this is coming in at 199 millimeters. Yeah, so from one side of the shell, the internal, like where the coupler pocket would go, to the other side of the coupler pocket, we're looking at 199 millimeters. And looking at the assembled chassis, again, all I did here is just, let me just take this apart for you. all I did here was to make sure that these holes would align with the fuel tank casting. Because if the holes don't align, then your chassis just won't work. It needs to align with those holes. So if you're making this, the rear half is measuring in at 97 millimeters. And the front half is measuring in at I'm going for 12 or 13. 12. And so that when I put the two together, again, use the panhead screws that are provided. They're just little tiny screws. Kind of hard to do this on camera as well. Line your holes up. There we go. Thought I had it. And where'd the other screw go? Oh, that's great. Oh, there it is. It's in there. You don't want to go in sideways. Make sure that you're actually going in straight with the screw. Okay, there it is there. So I'm going to measure it coupler pocket to coupler pocket. It should be 199. And it is exactly 199. So that when you put it in the frame, or the shell, sorry. I don't know if this is going to fit because we have to mill out the yeah, it's not going to fit because we need to cut this plastic piece off in order for the fuel tank clearance. But we've measured it and I know for certain it will fit. Okay, we're now going to work on trucks and truck assembly. Okay, so we got one of the truck castings here and I've filed it down. We're going to take the gear assembly and we're going to put one of those washers, decimal 1, 2, whatever it is. I forget what it says here in terms of part number. I think it's 2017. I can't find the exploded parts diagram right now. Hold on. I'm going to tell you what it is. Nope. Yeah, decimal 012 flat steel washer. So we're going to put that on here on one end. And we'll get another one of those washers. Put it on the other end. Now you're going to take one of these bushings, put it on. See the ridges? I don't know if you can see that in camera. The ridges. The ridge will go towards the washer, the large side. And now, this I only know through experience. We really don't want this gear assembly rocking back and forth inside the truck assembly. So what I've done in previous installations is I got these number 4 flat washers and I added a washer to one end of this gear assembly. and then I add the other bushing. And I just drop it in here, making sure that the ridges, I don't know if you can see that in camera, but there's 3 sides that have ridges, and then there's one side that does not. Well, the side that does not have a ridge is the side that's facing up. So you'll notice now, with the addition of that washer, that gear assembly is not as free to rock back and forth inside that truck, which is what we want. We don't want the gear assembly wobbling, you know, left and right all over the place. So there it is there. I may need to do a little bit more filing just to get that gear assembly really snug in there. You'll want to do the same thing with the other truck here. You gotta file it, and again making sure that there's very minimal play, the back and forth play, very minimal play in the gears. Okay, the trucks require an extensive amount of filing, so I just spent probably a couple hours doing it, actually, just getting it so that there's absolutely no binds in the truck assembly. So again, you may need a piece of track just to go put this on the track and then feel for any binding. And also, you know, let's have a look here. The washers I've used, I used the one that was included on the one end, and on the other end I used the other one they included plus another one that I added, just to prevent that play back and forth inside the truck assembly. So again, when you put this back in, making sure the bushing without the ridge is actually facing up. And then when you put the wheel sets in, make sure, like, have a look here, you can see that one side of this is insulated, the other is not. Just make sure that both sides line up. So insulated is on one side and not insulated is another. And again, try this on a piece of track. If you feel any binds, you're going to have to file some more. Okay, once you've taken care of that, you can then turn your attention to the other truck. So the one truck here, the one with the gearing, has to be super smooth in terms of free rolling. There can be absolutely no binds whatsoever, and you may need to file several areas of the truck assembly to get it to move smoothly like this. Even in this one here, which isn't that crucial, you may need to file quite a bit around the trucks here. I had to file this area in here, the opposite side as well. So, and be very careful about filing here, because this is where your axles go. If you file too much, the wheel will sit too low. Same goes within here. If you file too much, your axle assembly will sit too low and the gears won't properly mesh. So you want to take extra care, precaution in filing and doing constant checks to see whether or not you have the correct, you've correctly filed enough off. You can see here there's a bit of flash left over. I don't believe this area is needed, so I'm just going to leave things how they are. The real truck that does the business is really the one with the gears. And again, it has to be ultra smooth with absolutely no binding to be effective. And to put these together is pretty simple. Just take your bushing and your flat washer. You can see it there. In this particular one, I don't need to add any extra washers. It fits pretty well. So again, just make sure the bushing with the flat side is the one that's facing up. If I can get it in there. There it is there. Again, make sure that these gears are not rubbing or touching against the truck assembly. So you may need to file in there if there's anything being caught or stopping the gears from turning. I had the problem with this one actually. I had to get the file and file deep down in there because the gear was catching on metal. So take extra care in what you're doing and doing constant checks, like I said. Now when you're putting these things together, just make sure, like if this is your front truck, let's say the insulated wheels are on the far side, make sure that when you're putting together the trailing truck, the insulated wheels are on the opposite side. So kind of like this assembly right here. So there's kind of your front and rear truck, right? So you're going to have the insulated side, for example, over here, and that'll be your pickup, your right power pickup. And in this case, your insulated side for the trailing truck will be the one closest to you, with the power pickup over here. We're going to be wiring this for DCC, so again, we have a right rail pickup and a left rail pickup. Okay, so your plate covers, your truck covers, you can put those on now. If you tighten these too much though, you may find the wheels bind again, in which case you can either loosen off the screw, less tension. You may need to file in this partition here, because what would be happening if you're having any binding is that your gear is likely catching rubbing in this square area. So you may need to file out just a little tiny bit out of here. Okay, let's put the trucks together then and move on to the next step. Okay, next step you want to do is you want to take this gear tower, and we're going to assemble it and put it on the drive right here, the gear assembly. So take your gear tower, the two long screws, and screw that in there, and then you want to make sure that everything's turning freely. Okay, I have the tower assembly on the truck. I had to file the bottom of the tower, as well as remove some flash around the screw area here. So I got it turning freely here, and you can see it's turning the gear. Okay, we're going to turn our attention back over to the chassis. One thing I forgot, I got to go back and fix, is I have to install this pillar block. It's for the flywheel, so I have to take the fuel tank off and take it apart, because there are two holes. I didn't see them because they have some flash in them. They're right there. So the pillar block has to go in first, and we can't really, then I have to cut the bottom of the screws off, then reattach the fuel tank. So we're going to do that right now. Okay, I added that pillar block. So what I had to do was take the fuel tank off and take the two pieces, undo the two pieces here, because you had to screw in from underneath to put the pillar block in, and I just used the flathead screws to do that. Then I assembled it back together. This flathead screw here went through. I'm gonna have to file that down, cut it off, because that's kind of where the universal goes, and because it's protruding like that, it could interfere with the drive, so it should be cut and filed. One other thing I didn't do from the beginning, these pegs, not really needed, so I'm going to get my saw out and cut these off, sand them down, so they're not needed. So I got to do that yet. Okay, the pillar block has been put on the chassis, as well as these pegs from the fuel tank were cut off, sanded. So we're going to now turn our attention over to the motor. I'm going to take this piece and I'm going to get my hobby knife and cut the two apart right there. Okay, with those two pieces cut, you can see what I've done here. Take the longer screws that were provided with the motor, and you're going to put this mounting bracket in the chassis. You're not going to tighten it down all the way, and you're going to take the motor and you're going to fit the other piece of plastic over top of the shaft of the motor, and then screw in the plastic mount. Make sure that when you're putting this piece of plastic on the motor, you're paying attention to the polarity or the orientation of the motor with positive on top. Okay, so what's going to happen once you get that piece of plastic mounted to the motor, you can kind of see what happens here. It's going to mount in the frame, or sorry, in the chassis like this, and you tighten it down. Okay, so we're going to do that now. And you can sort of see what it would look like that. One thing I forgot to do, which we're going to do now, is we're going to have to mount this coupling to the end of the motor. Okay, when you're press fitting the coupling to the motor, just be careful not to press the shaft completely through the coupling. Okay, you can kind of see it in there, not to go too far. You just don't want any metal to metal contact there. The shaft, the socket will be turning a ball bearing or a piece of plastic here, a coupling. So as best as we can, we don't want to have metal against metal here. As I said, this socket will be turning this other socket. Okay, so hopefully you can see that. We don't want to press it all the way through. Okay, now we can mount the motor. Okay, on the one truck, I just went ahead and added the other socket. I'm going to have to take this apart now, just because we're going to be mounting the truck assembly to the frame. In the course of making this model, you're going to end up taking it apart and putting it together again. Probably several times, just because of different steps required. Like, I'm going to be painting mine, so it's going to have to come apart again. I'm going to DCC it, and so with the wiring and stuff, I mean, I probably will have to take it apart just for wire management and stuff like that. So we'll see how things go. So just take your gear tower off for now. And we're going to mount the trucks. So again, it's your front truck. Goes in there. We don't need the motor right now either, so we're going to have to take it off. And we'll put it back on a little bit later. Come on. So there's the rear truck. Just goes underneath. Oh, you probably want to get the socket for the other one and put it on right now. So we'll do that. Not that one. Yeah, when you push these things, it's a press fit, so I like to work on a flat surface and just sort of press down. Be careful not to press too hard. didn't go on. Anyways, we're going to continue putting the trucks together and, well, mounting it to the chassis. So I'm just going to take this brass bushing here, place it in the hole, and one of the longer screws, I believe, just through the hole there. It's a bit of a correction here. It's not one of the longer screws, it's one of the small flathead screws. What you're now going to do is you're going to take this piece right here, and we're going to get these plastic inserts, and they go on both sides of the they're mounted across this bar right here, and then that's what you use to mount the truck. If you can see that. Okay, so that's our next step. Bit of a problem here. The piece that was included, the holes aren't all the way through, so I'm going to have to drill those out before I can mount the front truck. One other thing I may have forgot to mention, if there's too much of this axle sticking out, it could interfere with the coupler mount. So I just took my saw and cut off the excess. I don't think I had that problem with the rear truck. No, I don't think so. So the rear truck got mounted with a small flathead screw, like a little tiny one. And once I drill through this piece, it gets mounted on the front along with these bushings, plastic bushings, so that the front truck will be electrically isolated from the rear truck. So I have to, as I said, get my drill out and drill through that piece to make the holes. So I just use I believe it's a 5/32 drill bit and a smaller drill bit just to open up the holes here. So you can see it's been mounted. What has to happen is there's a small plastic bushing that goes on the top and at the bottom, and that will electrically isolate this truck from the rest of the frame. Okay, so I'm going to find the longer screw for it, but you can kind of see here the beginnings of a locomotive. Okay, now we're going to turn our attention over to the flywheel. Oh, this is broken. That's not good. Anyways, we'll take it out. This particular locomotive has 3 flywheels. So the orientation of the flywheel is like this. So what has to happen is this has to be screwed on. Okay, and then there's some bushings that go in between these pillar blocks. I don't know if I mentioned this particular pillar block, but it gets 2 flathead screws, and you need to put in this pillar block before you attach the truck. So you have to go from the underside of the frame and make sure, look at the orientation there of that pillar block. The flat side has to go towards the front of the locomotive. Otherwise, if you reverse it, the rounded partition is going to rub against the flywheel. So just be careful of that. Okay, I got to find some pieces here and I'll assemble the flywheel. Okay, so the flywheel has 2 of these plastic bushings. So you need to remove this flywheel and put in the bushing, and make sure you just follow that the flat part of the bushing is against the flywheel, and then it just neatly fits in the pillar blocks. In this case, it doesn't really matter the orientation of the bushing, because these are different than the bushings that were used for the gears. A little bit different. So I can do this here on camera. There we go. Nope, didn't get this one yet. What should happen if you did this correctly, the flywheel should go in those pillar blocks. There it is there. It should easily spin around. No binding whatsoever. You may need to file a little bit, perhaps from the frame, just in this partition here, or adjust the flywheel accordingly. Perhaps both. Just making sure that nothing is binding or catching. There's a socket that has to be fitted at the end of the flywheel, and that socket will attach to the universal, which then connects to the motor. Okay. Okay, one thing you may want to do, actually have to do it, you can kind of see here the flywheel protruding beyond the ball joint. That's going to have to be cut. Okay, so you're going to have to cut that off in order for the ball joint to connect to the other ball joint on the gear tower. So it's spinning very, very freely. No binds. So again, we're going to cut that end, I believe, off. There's a plastic bushing in the pillar block. We have the cover to the pillar block screwed in there. We have a brass bushing here, a plastic bushing. I had cut the screw a little bit, and we have the cover to the other pillar block, as well as the socket at the end. So when you spin it, there's no binding whatsoever. It freely spins. If you find it rubbing against anything, you can always go back and do a little bit more filing. Okay, we're gonna, I believe we're going to mount the motor and get the universal shaft, drive shaft here, cut these pieces, because now we have to again mount these pieces to connect to the motor. Okay, I measured from this socket to the socket for the motor, and then cut that piece of brass tubing they included to the appropriate length. The red socket goes in the motor housing, while the white one goes in the flywheel. And so when you turn the flywheel at this point, I mean, everything should move smoothly. I installed again the gear tower. So again, if you move that flywheel, you should see the gears moving freely, just like that. So it's looking good so far. All the gears are making contact, meshing well together. There are no binds. It'll be even smoother once we oil and grease it, but we'll wait for that a little bit later. I think we're at the last step, one of the last steps anyway, before we can put it on track. And we have to cut the universal for the underside and use the ball socket for the tubing. And I think that would be, oh, we have to wire up the motor yet as well, and then we're ready to test on track. So a few more steps yet to go. So for the last universal joint here, I didn't need to cut it at all. It was actually the correct length right out of the package. So you can see here the flywheel turning. It turns the gears, which in turn connects to the truck, and the truck then turns the drive shaft at the bottom ever so slowly, which then connects to the other truck. So like I said, we just have to wire up the motor. So for this installation, I just soldered the one wire to the body right on that screw, and the other wire goes to the other truck, which is electrically isolated from the rest of the frame. So that bushing in there is plastic, and there's no other metal to metal contact between the truck and the frame. Okay, I've hooked up a simple power pack, DC power pack, just to a section of track. I don't have a DC layout, I have a DCC layout, and I haven't hooked up a decoder yet. This is just simply to test the locomotive to see if it's operational. So there's the completed piece thus far. So we're gonna put this on the track to see if we get power. Success! Nice! Go the other way now. Okay. Excellent. Alright, so this works. What we're going to have to do now is turn our attention over to the frame. We're going to have, or the shell, sorry. We're going to have to fit the chassis inside the shell. Okay, for simplicity, I took the wires off the locomotive. We just don't want them. They're going to get in the way anyway, and I'll have to wire this for DCC a little bit later. Right now what we're doing is we're trying to fit the shell with the chassis. So when I go to do the initial fitting, there's an issue here. The issue would be there's ribs inside of the shell. So I don't know if you can see that in camera, but it's simply not fitting because of these ribs here. I'll point them out so you can see them. So there's ribs right here all along. I'll have to get out a Dremel tool and grind away at these ribs so there's clearance for the motor. In addition, I'll have to look at these pieces here because I think they need to be cut for clearance. So here's a look at my Dremel tool, what I'm using. I'm just putting a sanding wheel on the end of this attachment here, and all I'm going to do is just slowly go to the inside of the locomotive here and just grind away at this these ribs. So I'll do that now for you. So you can kind of see here in the model what I'm trying to grind away at. So this is going to take some time. Again, with anything, go slow at this, and then just try to get that motor, the rear half of the locomotive, to go inside the shell, and we can then determine how much we need to cut away from these pegs in order for the complete fitting. Okay, I'm going to keep on sanding. Okay, we're getting there. You can see here now the motor actually fits inside the rear end of the locomotive, and you can see how much sanding I did. I just took out those ribs along the side. Great thing about Tyco plastic, it's really thick, so this shouldn't take too much longer. The real issue now, looking at this, happens to be this clip. I'll show it to you. So I'm going to have to get out a different attachment for the Dremel tool and sort of cut this partition, this part right here, so that the fuel tank has a little bit more clearance. Likewise over here, you can see it, right? You can see the fuel tank hitting this piece of plastic, so this part has to come off. I wouldn't cut the whole thing, just because I'm going to paint this black and sort of give it the illusion of sort of like the motor and all the other gutty works of the locomotive. So I'm going to leave this part, I'm going to leave part of it and then color it or paint it black. Same goes with the front here to do the same thing. And I think once those two clips have been cut, the shell should go on the frame. So I just got out a magic marker and sort of guesstimated where I need to do the cutting. You can kind of see that there on camera. And I've switched out from the sanding wheel to the cutting disc. And so I'm just going to, again, go up, cut these tabs off as best I can, and then probably switch over to another tool and just sand it flat without, I don't want to cut in the sill area here, so as much as I can I'm going to try and get the cutting wheel through there and then sand off the rest. Okay, we're getting there. You can see I've cut those tabs here. I still need to sand them, but you can see here there's at least clearance for the frame and the fuel tank for the shell. What's really preventing it from fully seating is still I have to sand out the ribs towards the front of the locomotive. It's just binding. It's binding in this area right here. So I have to change tools again, sand these ribs off, and then it should fully seat inside. One thing that I also may need to do, we'll see what happens, I may need to just sand out a little bit of the coupler pocket to fit. I might be off by 1 millimeter or so. Okay, just some more sanding now. Okay, it's almost fully seated. You can see I had to mill out quite a bit from that tab there, both the front and the back of the tab here. Honestly, you won't notice a difference once I paint it black. The rear, I just cut the one side here, and you can see the clearance now for the fuel tank and the remaining part of the chassis. If you look at the front, I'm off by about 1 millimeter or so, maybe 1 millimeter. I'm just going to have to sand a little bit just to get a tight fit in there. What's really preventing the locomotive from fully seating right now, I'll show you, is these two tabs right here at the top. So get out your hobby knife, or you could put another Dremel tool on there, whatever, but you're going to have to cut these off. And it's just that I believe the flywheel is, or the motor is touching here, and it's just not able to fully seat because of these tabs. I may need to do a little bit of further sanding in around the cab area just for that large flywheel. You can see that ridge right there. So a little bit more sanding and it should fully seat. Success. So there you go. I didn't actually need to sand anything from the coupler pocket. It is a super tight fit, so it's a pressure fit. I can pick it up and chassis is not falling out of the shell, which is good. Yeah, so really happy with the way it turned out. You can see it's fully seated in the shell. Okay, what I'm going to do now is I'm going to take this apart, take the shell off, and I'm probably going to end up painting the side frames and the fuel tank. That's going to be my next step, and then we'll wire the decoder in, and then we'll do some cosmetic details like fixing these handrails, and yeah, then we'll have a completed model. So really happy with the way it turned out. Just so you can have a final look at the shell on the inside there, if you're doing this yourself. You can see how much I've sanded off, cut to get that chassis to fit. It's not that much work. Okay, I necessarily had to take the whole thing apart because now we've reached the stage of painting. I'm just going to take this bare metal, tape it up. Some parts you're going to want to paint, others you're going to want to keep as bare metal, like this top part right here. I mean, there's no point in painting that. Some areas of the truck assembly shouldn't get paint on them either, like in the insides here. You shouldn't get paint there. So some parts will need to be masked and before we can start painting. So that's going to be my next step. Okay, I just finished masking. I'm just using cheap green painter's tape. Yeah, it's there's this painter's tape, regular painter's tape. I'm not perfect with the masking. It doesn't need to be. We're going to be painting this flat black, and if there's bleed through, big deal, because it's going to be covered by the shell anyway. I just want to try and get this side sill, fuel tank, and the front of this coupler pocket and the rear. That's what's going to be visible from trackside. The rest of it's just going to disappear into the shell. We won't see it anyway. Regarding the trucks, I just protected the holes as best I could. Stuffed a few pieces of tape inside the truck assembly just to minimize the amount of paint that's going to go in there. So just going to try and, as much as possible, avoid getting paint inside the assembly. And okay, so let's be cut a little bit here. The tape, I forgot. So we're going to try and get the front of the truck here and the rear as well. Regarding the bottom, I put painter's tape just on the underside. We want to protect the inside of the truck assembly, and so we'll spray paint the bottom. You may, more importantly, you're going to see this side from track side. You won't see the bottom. So, alright, we'll just set up for painting, and we'll give this a coat of flat black. Okay, I'm pretty much ready to spray bomb this stuff. I'm just using some cheap Testors flat black spray enamel, and my spray booth is just simply a cardboard box. It'll take several passes because I'll have to spray and then turn the pieces around to get the other side, so it'll take a few sprays, a few passes to get everything. So there's the first pass. Like I said, we'll wait a few minutes, let this dry a little bit, and we'll slowly just turn them around. We'll also want to do the truck side frames, getting those painted black as well. Okay, the last pieces are drying. Once they're done drying, I'm going to hit them with this Krylon matte clear finish, just seal in the paint. And I just finished up brush painting these tabs, a flat black. I'm using for that Tamiya XF1 flat black. There it is there. So in addition to those tabs being painted black, I've also painted around the rear headlight and around the front. And the reason I did that is to prevent light bleed through. So when I put LEDs in this thing, we don't get light shining through the roof. Okay, one thing I should have probably made mention, I popped out the lenses for the front of the locomotive. I'm then going to, and when I get around to installing the LEDs, I'm probably going to end up cutting them a little bit, just so there's room for the LED. Okay, so I'm going to do that for the front. For the rear, I'm just going to get my X-Acto blade here, just press in about the center of where the headlight would be, and then just get a simple pin vise and drill out the cavity for the lens. Okay, the holes are drilled out. Normally I would use incandescent bulbs, but I'm going to be using LED lights just because this is a DCC decoder. So I have these extra grain of, I think it's, yeah, grain of rice bulbs. I'm never going to use these, so to me they're no good, they're junk. So what I'm going to do is I'm going to cut the lead away from the bulb. Then I'm going to shove the bulb in the hole here, and then I'm going to light the, or put the LEDs behind the lens, the bulb. So that's how I'm going to do it. If you don't have extra grain of rice bulbs, and you still want lenses on your locomotive, a product I was told to use was called Bondic. You can see it there on the Amazon page. Apparently that's pretty good for making lenses, but I'm going for the cheap option of just using what I have. Okay, so the locomotive came out of paint. It looks pretty good. Nice flat black. Everything's assembled again. I got a piece of styrene, and I'm going to have to find some longer screws, and I'm going to have to trim this to size, but because we need to make a platform for the decoder. It needs to rest somewhere. So I'm going to make a platform for the decoder, and then we can wire in the decoder. Okay, I just took a piece of scrap styrene and mounted it on top of the pillar block here, and then I just cut a hole in the middle just to give the socket clearance. This is where the decoder is going to sit. So I can spin this. Flywheel around, and again, nothing is going to hit that piece of styrene. So that's where the decoder is going to go. One thing I can do before the decoder goes in is I can install the side frames, and I can oil the trucks. So in oiling the trucks, I'm just using this Labelle 107 oil. Again, just a few drops, not too much here. And then the truck, or the side covers, they just, I don't know if you can see right here, this is just a screw that goes in the back, and they just sort of, they slip in this little pocket right here, and you just tighten it up against the truck assembly. You kind of get the idea here. Okay, so we're going to do that for all 4 trucks. Okay, so in the course of putting on the truck covers, or the side frames, I discovered a problem with the truck cover. It's an easy fix, but these little tabs on the truck cover are simply in the way, so I can't complete this as is. I have to cut these off. I may need to repaint this, depends how much I scratch it up, but we'll see. Again, I have to cut these off, unfortunately. So there's the completed locomotive. Looks really sharp with the flat black application. I still have to install the decoder, and that's going to be the next step. I also have to install couplers. I'm not sure if I have to make my own couplers or modify some couplers. And I'm also considering, with the shell, filling in that cavity with a piece of styrene and leaving enough for the coupler of the new engine, and painting that red, maybe adding a snowplow, and I have to fix handrails yet. So next step is going to be, like I said, decoder and wiring for LEDs. So while I wait for the decoder to arrive in the mail, I just got some styrene and sort of guesstimated, size to cut. So what I'm trying to do again is just trying to fill in that cavity, make a real, true, genuine coupler pocket, something more modern day looking kind of thing. It's not perfect, it's a pressure fit. I'll glue it from behind, paint it red, maybe put a few air hoses on the front, and it'll blend in pretty nicely once the coupler is assembled and put in there. You won't notice it's you know, not perfectly square, but it's close enough, right? So got the front done, got the rear done, just have to glue it and then paint. So just finished putting in some styrene, filling up the little holes there. I'll paint it, and it'll look pretty good when it's done. So the styrene pieces have been painted. It blended in pretty well. It's pretty good. And the front pocket painted, looks pretty sharp. It's still a bit wet, so I may add a few air hose details, but it looks way better than it did as a Tyco. So we have handrails to do yet too. Well, I finally got a decoder today in the mail. I'm going to be using a Digitrax DH126D for the decoder. Simple two-function decoder, pretty simple installation. We're going to wire up the motor first, gray to the negative and orange to the positive. So there's your harness for your decoder. So I'm just going to strip back some wire and then solder it to the motor and then install the motor again. Okay, I got the harness on the decoder. I always find it very, very difficult to get the harness on the decoder. Also, I don't understand with what's with these decoder manufacturers. Like, I don't understand, why is the gray wire never next to the orange? Should be. I mean, they're both the motor lead, right? And same goes with the red and the black. They should be together. I mean, that's your rail pickup. So, you know, it looks straight coming out of the decoder, but it ends up looking like spaghetti simply because of the destination of the wires. So you have to find the orange and the gray for your motor lead, and inevitably they're going to end up being twisted up just because of where they're coming out of the decoder. Anyways, it's a pet peeve I have with that. Looking at the motor here, there's the negative. I don't know if you can see that in camera or not. So the negative, it's in the plastic anyway. The negative lead is the first one we're going to do, which is going to be the gray wire. So let's get out my soldering gun, a little bit of flux. Oh, you can't see, sorry about that. And a little bit of solder. It'll be real quick. Solid connection. Flip the motor over. We'll just do the orange wire now. Perfect. Okay, we'll install the motor and then we'll turn our attention to the left rail, right rail pickup. Okay, actually before we install the motor again, you can kind of see here where the decoder is going to sit. One thing I have to do, I'm going to have to solder, I believe it's the black wire, the left rail pickup. I want to solder it to this screw. And I'm going to cover this screw with like electrical tape. And the reason I'm soldering it to the screw is that's going to be where it picks up power through the chassis, right? So this truck will be you'll get the power from the left side, which comes through the chassis, and the right truck gets power through the right side of the wheel here, which is the engineer side. Remember, this is the front of the locomotive. So the front of the locomotive, right side is engineer side, which is the red wire. Left side, conductor side, is the black wire. It gets power through the chassis. So I'm just going to, as I said, strip the black wire now, solder it to this screw, careful not to mess up the screw head, and then cover it over with some electrical tape, and then mount the motor. Making sure that there's electrical tape in this whole area here, so that there's no possibility of metal-to-metal contact between motor and chassis, because we want to electrically isolate the motor from the frame. It's a kind of a rule of DCC. You can't have metal to metal contact with the motor and the chassis. Okay, it'll create a short circuit. And then poof, your decoder will go. Okay, so yeah, like I said, we're just going to wire up the track lead, or the leads now. Okay, this looks worse than it really is. Pretty much it's wired for DCC already right now, so just to go over with you a couple things here. So again, orange wire is the positive lead from the motor, gray is the negative. Okay, we have a black wire, which is the left rail pickup. It's soldered to the screw head, which is connected to the the trucks here, which is the chassis pickup. The red wire is connected to the trucks at the front here. That's your right rail pickup. I kept the wire that came with the motor because I wanted that that little O-ring kind of connector. I don't know if you can see that there. Sorry, it's not really focusing. Yeah, so I wanted that connector. It's not touching the flywheel. I know it may look like it on camera, but it's not. And that's why this tower is here, kind of thing. So you just sort of put the wire there. It's not binding or rubbing against that wire. It's fine. So at this point in the game, it's ready to go on rail. The only thing that hasn't been wired, which is really intimidating, I know it looks pretty bad here, but all these are your lights. So we're over here at the computer. We're just going to see if the decoder works. Might as well take care of that. So I'm going to find JMRI. There it is there. And Decoder Pro. So there's some other locomotives I've programmed. So what we're going to do is we're going to put it on the track. Yeah. It's on the track. So I'm using a Sprague 2 DCC programmer. That's connected to the computer and power and track. I also have a load programmer. Okay, so we're going to go new locomotive, and then we're going to click on read type from decoder. Now we hear a little bit of life in the locomotive, which is good. Okay, it's identified the locomotive as a Digitrax, which is correct. The DH126D, and we're going to have this, we're going to call it the Canadiana. (4301). The address is going to be 4301, and we're going to hit write. Save. We can close this window now. You can find it in our roster, the Canadiana 4301. Right click, we're going to bring up a throttle. We're going to turn on the throttle. Okay, at this point in the game, we should go forward and backward. Okay, that's good. But we got binding. It's binding for some reason. Okay. It wants to run, but there's something binding there. We're going to have to look at things. Okay, I think the issue was that the socket was tight against the pillar block, so I had to take it apart and then pull the socket so away from the pillar block so it wasn't so tight. Alright, let's try this again, hopefully with a little bit better result. Alright, this time. Still got some binding, eh? Better, but okay, this time I cut a little bit of this universal. I thought it was a little bit too long, and so what I was doing when I assembled this is I was forcing the motor this way, and that so that the universal is too tight against the socket. So it's loose, definitely loose, no binding. So we're going to try it out, see how it works. So we'll turn it on, bring up a throttle, on. Okay, let's try forward now. Forward. Oh, got nothing. Uh-oh. Okay, this time I had to take the whole thing apart, well, from this assembly, really the whole thing, because I had to file away the chassis because there wasn't enough clearance for the flywheel. The flywheel is binding against the pillar block, so had to file that. But now it works no problem. Here it goes. Nice smooth action here. No problems, much better. Okay, we have lights. I think just forward lights right now. So we have two forward lights. There they are there. LEDs. I'm using warm white LEDs with a 470 ohm 1/4 watt resistors. So the resistor package is right there, hope you can see it, and that's wired to the white wire, both resistors, and then that goes to the black wire, negative for the LEDs, and then the positive is connected to the blue wire, the common wire. So there are two lights for the forward light, the bulbs, the lenses, so I'm gonna have to wire two more for the rear, and then we'll start installing and gluing in the LEDs in the appropriate location. So far so good. It's still operating too. That's correct now that what I've done, I put it in reverse and it should go backwards. I just reversed the wire connection on the motor. There we go. Maybe not. Come on, you. Oh, off the track. Ah! Sorry, it was off the track. So go forward again. Come on, forward again. There we go. Oh. Reverse. Okay, so far so good. Just got to wire up the rear LED now. Okay, forgive the bird's nest of wires here, but we got it. So there's your forward two lights, and now your reverse two lights. There they are there. Forward, reverse. Okay, it looks pretty bad right now, but it's just down to wire management now. So we have here the red wire is connected to the blue positive common. So there are 4 leads coming out of the blue wire, and there's 4 resistors. So for each negative leg of the LED, it gets a resistor. So these 2 bulbs then will be glued into the shell for the front, and these 2 for the back, and then just, you know, a little bit more wire management, and then we should be good to go. Starting light installation. You can see I've done one of the LEDs, and I've glued it to one of the lenses. So I'll have that glue, and then I'll do the other lens in the front. Likewise in the back. I don't know if you can see that, but get the light in there. I got one lens gluing there in the back. So we'll get the lenses glued in, and we'll do some final fitting with the wire management here, and I think we should be good. Okay, we're starting light installation. You can see I've done one of the LEDs, and I've glued it to one of the lenses. So I'll have that glue, and then I'll do the other lens in the front. Likewise in the back. I don't know if you can see that, but get the light in there. I got one lens gluing there in the back. Okay, what I thought would go together pretty quick. It's taking quite a bit of time. Yeah, the locomotive works and all that, but quite a bit of milling required to get that large flywheel to freely go back and forth. You can see all the filing I've had to do around the roof line, as well as near those doors. So yeah, it fits on the shell no problem, but that flywheel is the issue. So after several weeks, my Tyco DCC project is finished. Certainly not for the faint of heart. Real challenge to get it done. You see some of the details there. It's a pressure fit, but it's very, very solid. It's not falling out. Measured to the millimeter. You have to get the chassis off the shell, you have to actually push a little bit of the snowplow forward a little bit, and then it releases. But it is a very tight fit. Still, you should always pick it up by the fuel tank. You see the lenses I made. So there's a Tyco model running DCC.